Hello and welcome to our third learning path in AI-300, Operationalize Machine Learning and Generative AI Solutions. I'm Barbara Andrews, Microsoft Technical Trainer here at Microsoft, and I'm so glad you're here. Let's get started with this session. Imagine a team building an AI agent to help employees search internal knowledge and answer operational questions. The technology works, but the real challenge is managing prompts, improving responses, and making sure the agent keeps getting better over time. That's where GenAIOps comes in. In this session, you'll explore how to plan and run AI agents as reliable solutions in Microsoft Foundry. You'll see how to manage and version prompts with GitHub and how to evaluate and optimize agent behavior through structured experimentation. So instead of experimenting ad hoc, you gain a repeatable, disciplined process for improving AI agents, helping teams move from one-off demos to trustworthy, production-ready Gen AI solutions. Imagine your organization launching an AI agent that answers employee questions, summarizes documents, or assists customers. The agent works well at first, but over time, prompts evolve, responses drift, and improvements become hard to track. That's where GenAIOps comes in. In this section, we'll explore how you can prepare GenAIOps solutions, designing a structured approach to building, managing, and improving AI agents with Microsoft Foundry. The goal is to move beyond one-off agent experiments and create repeatable, reliable systems where prompts, evaluations, and improvements are managed as part of an ongoing operational workflow. Imagine you're building an AI support agent for employees that answers questions about company policies and internal tools. For that agent to be useful and trustworthy, you need to have more than just a prompt. You must define what the agent is supposed to do, who it serves, and how you'll measure success. Getting this right up front means the agent delivers consistent, reliable help instead of unpredictable responses. Defining clear agent specifications starts with user intent, the job the agent performs, the target audience, the problems it solves, then outlines the prompts that guide its behavior, the capabilities and restrictions such as the tools or data the agent can access, and how performance will be evaluated with a rubric or shadow ratings. Finally, prepare test data, including smoke tests and automated evaluations to validate responses. By designing these elements early, you create a clear blueprint for building, testing, and improving AI agents in a structured, production-ready GenAIOps workflow. Remember to treat agent specifications as a design blueprint for GenAIOps. Define clear prompts, capabilities, constraints, and evaluation criteria early so your agent can be systematically tested, iterated, and improved as it evolves in production. Imagine you're building an AI agent that helps customers troubleshoot technical issues. Instead of picking a model blindly, a structured approach lets you shortlist a few candidate models, evaluate them across real-world performance, capability, and operational cost, and then compare them using the same test prompts and scoring rubric. This method prevents teams overemphasizing for just raw model quality, ensuring the final choice also fits latency, cost, and system constraints. Selecting the right model should be deliberate, not trial and error. Start by choosing 2 to 5 candidate models as a lead option, alternatives, and possibly a backup. Then evaluate them across 3 critical dimensions: performance, like how they handle real-time complex or batch workloads, capabilities, like reasoning, domain knowledge, tool usage, language support, and operational fit, like latency, infrastructure needs, and costs. Finally, run the same smoke test prompts across all the candidates and score them with a consistent rubric to compare results objectively. Select the model that achieves the best overall balance of quality, cost, and operational efficiency rather than optimizing for a single metric. Navigating the GenAIOps lifecycle shows the practical path for turning an AI agent idea into a reliable production-ready system. The flow moves through discover, build, deploy, and operate. In the discover stage, you define the business problem, identify the right models and data, and test initial prompt ideas. In the build stage, you develop the agent, connect tools and knowledge sources, refine prompts and configurations, and iteratively evaluate results until the system works as expected. Once ready, the deploy stage packages and publishes the agent for managed scaling and real-world usage. The life cycle doesn't stop at deployment. In the operate stage, teams monitor cost, safety, and performance, mitigate risks, and integrate the agent into business workflows while continuously improving it. Imagine a company launching an IT support agent. It starts as a prototype answering common questions, then evolves through prompt tuning and tool integration. And then it's deployed as a scalable service and eventually becomes a monitored production system that employees rely on daily. Treat agent development as a continuous loop. Discover, build, deploy, and operate using real usage data and structured evaluation to keep improving the agent's accuracy, safety, and business value. Now let's see which tools support each phase of the GenAIOps lifecycle, from early experimentation to production operations. Teams begin by rapidly prototyping agents with tools like the Azure Developer CLI, templates, and chat playgrounds. As they progress, they customize and enhance the agent with retrieval augmented generation, or RAG, enterprise data from Microsoft Fabric, and tool integrations. They then experiment and evaluate using prompt templates, evaluation frameworks, and tracing to measure behavior and improve responses. Finally, the agent moves to production, where services like Foundry, Agent Service, GitHub Actions, and Azure Monitor provide deployment, automation, and observability. Consider a company building a customer support AI agent. Developers prototype responses in the playground, enrich answers with company knowledge using Azure AI Search, test prompts and safety with structured evaluation, and finally deploy the agent with CI/CD and monitoring. What's the benefit? This life cycle and tool set help teams move from quick AI experiments to controlled, scalable, production-ready systems. In this exercise, you'll take the first practical step in operationalizing a GenAI solution. You'll provision the core infrastructure for Microsoft Foundry using the Azure Developer CLI, AZD, and set up the services such as the application insights that help monitor and manage AI applications in real environments. Think of this as laying the foundation for everything that follows in GenAIOps. Instead of manually assembling resources, you'll see how infrastructure can be provisioned consistently and repeatably. A key best practice for teams that want to scale and maintain reliable generative AI systems. Now it's time for our knowledge check. Question 1. Which of the following best describes GenAIOps? Answer: GenAIOps focuses primarily on the development of hardware designed for training large language models. Question 2. What AZD CLI command should you use to create all the project resources and deploy the app to Azure? Answer: AZD deploy. You've now seen how GenAIOps turns AI agents from clever demos into dependable, continuously improving systems by defining clear agent specifications, selecting models deliberately, following a well-structured life cycle, and using the right tools across discovery, build, deployment, and operations. Teams gain control over how agents evolve over time. This is the shift from prompt tinkering to agent operations, where behavior is testable, changes are measurable, and improvements are intentional. With a solid GenAIOps foundation in place, you're ready to build agents that don't just work once, but keep delivering safe, reliable, and scalable value as real users, data, and business needs change. Thanks for joining us for this session. To continue your learning, watch other videos in this course or explore more on Microsoft Learn at aka.ms/learn.